Hi, and welcome to Unit 8, Day 2. This is Part 2, Diluting a Solution Example Problems. So in Part 1, we looked at making solutions from a solid metal hydroxide base that we would mix in water, and then we would use that to find the concentration. Now we're dealing with our liquids. And the liquids, or liquid solutions, I should say. And what we're doing is we're taking one solution, a stock solution that's more concentrated, and taking a small amount out, adding water to that small amount to dilute it. Okay, so that's what we're doing here. And for those problems, we are using the M1V1 equals M2V2. You may also see this as C1V1 equals C2V2 because C just stands for concentration. But V in all cases stands for volume. Now the cool thing about this, the math is easier than what you've seen previously. Secondly, you don't need to convert the volume into liters because what happens is by converting, let's say you convert volume 1 into liter by dividing it by 1,000, volume 2 into liter by dividing it by 1,000. Since they're on opposite sides of the equal sign, they sort of, that operation cancels out. All right, so you don't need to convert it to liters. You can just keep it in milliliters, which makes it easier. Okay, so let's get started. 50 milliliters of a 0.8 molar HCl stock solution. So we have our information. So we have the volume of our stock and our concentration of our stock. It's diluted to make 400 milliliters solution. So we have the volume of the diluted solution. That's going to be my V2. And my V1 will be the volume of my stock solution, and the M1 will be the molarity of the stock solution. Okay, so what is the concentration of the diluted HCl solution? So to do that, we would plug our information in. All right, so molarity here, I got 0.800 molar. I'm just going to ignore the units for right now. I'm not going to put them in, just to make the math look easier. And then so it's 0.8 times 50. And then my M2 is what I'm looking for, because I want the concentration. What is the concentration? M2 is equal to question mark. And my V2 is going to be the 400 milliliters. So as long as your units are the same for your volumes, you don't need to divide it or convert it to liters. All right. So we have 0.8 times 50. So that's going to give me 40 on this side. And then I'm going to divide it by the 400. So the molarity 2 would be 0.1 molar. So in case you wanted to see that out, it'll be 40 here is equal to M2 times 400 divided by both sides by 400. So you can isolate the M2. And you get M2 is equal to 0.10. I think I have 3 sig figs here, molar. All right, so now we have the concentration of our diluted solution. So we started off with a solution that has a 0.8 molar concentration, and we diluted it down to so that the concentration becomes 0.1 molar. It's a lower number, so it's less concentrated. Now what we're going to do is we're going to use it to calculate to get the pH. So remember, pH is equal to the negative log of the concentration of H+. I don't have the concentration of H+, I have the concentration of HCl. But just like in the case with strong bases, for strong acids, when you dissolve them in water, they ionize into the H+, the acidic proton, and then their anion, right? So you can see here, this is a 1-to-1 ratio. If you have 1 HCl, you would have 1 H+. So that means that their concentration, the concentration of HCl, if that concentration is 0.00 molar, then the concentration of H+ will also be 0.100 molar, okay? So now we actually have the concentration of H+. It's the same as the HCl. So we're going to get pH equal to the negative log of 0.1. Plug that in. So negative log 0.1, and then I get pH is equal to 1. Okay, and then in terms of the work here, If the pH is equal to 1, we can use this information to get the pOH. Remember, pOH is going to equal 14. Let me just box this off. Minus whatever the pH is, so 1. So that's going to be 13. Because they're sort of inverse of each other. Okay? Cool. All right, let's go ahead now and do the last problem. So in this problem, we are given 10 milliliters of a 12 molar H2SO4 sulfuric acid. Stock solution is diluted to 1,000 milliliters. What is the concentration of the diluted H2SO4 solution? So we have our V1, we have our M1, and we have our V2. We're looking for M2, okay? So we take the 12 molar, multiply that with the 10 milliliters, 10.0, and then set that equal to the M2, which is what we're trying to find, and the 1,000. So we get here 12 times 10 is 120. And then we divide both sides by 1,000. 120 divided by 1,000 gives me an M2 of 0.120 molar. So the concentration of this diluted H2SO4 solution is 0.120 molar. So we went from 12 molar all the way down to 0.120 in this dilution. Wow. All right, now we need to find our pH. Our pH is equal to, of course, the negative log of concentration of H+. All right, so remember, we need to figure out how many H pluses we have, or what's the concentration of H plus from the concentration of H2SO4. Now, you may be thinking, all right, well, I've seen enough of this. I know what's going on here. If I were to dissolve H2SO4 in water, it's going to give me 2H plus and SO4 2 minus, right? Actually, acids don't work that way. Bases work that way. If you have two hydroxides, it's going to break apart into two hydroxides, right, for strong bases. But for acids, removing the hydrogen, that acidic proton, you have to do it step by step. So the way that it actually looks is H2SO4 goes to form H plus HSO4 minus. Now then the HSO4 minus can lose a proton as well since it's still in water. But this first step here, this single removal represents your strong acid. Now, so most people, because this is the strong acid, this is the dominant acid, this is also the dominant process in solution. So now most people do is they just use this information, right? They don't go any further with, this is actually a weak acid. So HSO4 minus going to form H plus SO4 2 minus, right? So they don't usually go further than this if you're calculating the pH. If you want to be very specific, you can, but in most examples, this estimation just using this information here is good. So what is that to say? For any of the strong acids, even if it's H2S4 has two hydrogens in it, your concentration of H plus it's going to come from it's going to be equal to the molarity of your acid. Now, of course, I said that this is an estimation, so if you get to a higher grade like in college or in AP, they will show you how to actually do this, okay? They will show you how to use this to get the concentration of H plus as well. But in our class, for right now, we're fine with just using the concentration of H2SO4. So I'll repeat that. So whenever you're dealing with an acid, the concentration of H plus is going to equal the concentration of your acid. Okay. Now for bases, that's not true. You need to count the number of hydroxides. But for acids, make it easy. Okay, so now we can go on. So here the pH is going to be negative log, whatever the concentration of our acid is. So that's 0.120. Plug that into my calculator. Negative log. And I get 0.921. That's a pretty low pH, which tells me this is a pretty strong acid. Remember, the lower the pH, the stronger the acid. So now my pOH is going to be, oops, sorry. It's going to be 14, much easier than that, minus my pH. So it's going to be 14 minus 0.921. 13.1. Okay. So my pH is 0.9 and my pOH is 13.1. All right, that is it for this video. Have a quality day.